Welcome everyone. In this video, we will continue analyzing the data from our expert advisor portfolio. If you like what I do, don't forget to subscribe to the channel and leave a like on the videos. So let's pick up from here with our database of all the trades we've made with the various expert advisors during this 4-year test period plus 10 months of out of sample. The first thing we need to calculate, which will be useful to us, is the composite equity line curve. How do we calculate this equity line? In my case, I decided to start with an initial capital of 10,000 euros. So in this formula, I use the first trade and calculate the initial capital. So basically 10,000 plus 10,000 for the first capital. The first trade made a profit of 1.18%, which I have in cell S. So S2 for this value. This is a factor that we will use later on as it modifies the risk of our portfolio. Because in case we started with too high a risk, at least we can assess what happens if, for example, we reduce the risk of the entire portfolio by 0.5, so we use it with halved risk. Or if we started with a risk that is too low, we can, for example, double the risk, so we multiply by 2 and apply it directly to our profits and losses. Because if we double the risk of the entire portfolio, the profits and losses will certainly be exactly double as well. The same goes if we halve it, it will be half. So this will be very useful for us later on. After that, we continue to calculate all the exceptions in the same way. Once we have set up the formulas, we drag them down to the bottom of the sheet. From here, we can then go on to calculate the drawdown. So let's see, using this formula, how we calculate it on our equity that we have just computed. So you see, cell X1 minus cell X3 divided by the maximum between X2 and X3, and then as you go down, the maximum will be the total. This way, you calculate all the drawdown percentages in our portfolio. In this case, it's 0 because here we're not in drawdown. Our equity is continuously reaching new highs, so we don't have any drawdown. From here, we can then calculate a whole series of other parameters, which I won't explain how I calculated right now, but I will show you the results. If you're interested in knowing how I calculated the parameters, let me know in the comments and I'll explain cell by cell everything we've calculated. So let's go see what we've calculated. The parameters that I considered interesting are these. So I divided them between the total period of my data, meaning both the test and the out-of-sample period and the out-of-sample period alone, where everything ran without any optimization. The first thing I went to calculate, let's take a quick look. The first thing I went to calculate was the maximum percentage drawdown. In this case, I had a 33% drawdown in total in the part where I had also optimized, and a slightly lower drawdown in the out-of-sample period. This doesn't mean that the system performs better out of sample compared to the backtest. It probably just encountered a slightly more favorable market during the last 10 months. In my opinion, it's very important to then go and calculate the standard deviations. The first thing I notice from these values, however, is that we have an extremely high drawdown because 33% is not acceptable, in my opinion. So, with that risk value we saw earlier, I would at least set a risk that is 0.3 compared to the current one, because I probably started with experts that took on too much risk. So I don't feel safe. I would never use a portfolio with such a high drawdown. So by changing this value, now all the data will be recalculated. Let's see. Now the drawdown has become reasonable. We have an overall drawdown of 11.5%, which is a drawdown that one can reasonably expect to handle. Also because in reality this drawdown could end up being even higher due to possibly unfavorable conditions like slippage, spreads, the broker, or maybe some news events. We could even reach higher drawdowns, but by starting from such a low value, we can be confident that we can absorb them easily without blowing up the account. We can see here, in fact, that in the next row, I calculated the percentage standard deviation relative to the drawdown. In my case, I have 1.67% overall and 1.45% in out-of-sample. I need the standard deviation because I use this standard deviation to calculate increased drawdowns with a certain probability that this drawdown will actually be reached. So I have what is called a standard deviation, and I calculate it in the following way, by taking my drawdown plus 1 time the standard deviation. Then the second thing I do is I have a 95% probability of staying within this value, so I add 1.96 sigma, which is the standard deviation, and so on. The last value, which is basically the limit, thank you, I have a probability of staying within this value of 99.7%. What does that mean? It means I only have a residual 0.3% chance of exceeding this drawdown, which is still 16%, so all things considered, it's reasonable. Is it possible to reduce this risk? No, because anyway, a model can't be built on such a restrictive condition that is still eventually reached. Only in 0.3% of cases, meaning it would be excessive to focus solely on this eventuality because this is a catastrophic event. And yes, it's accounted for, but the probability of it actually happening is really low, since 0.3% is a low probability. These are data that I can then also cross-reference with the results from the Monte Carlo analysis I did on Quant Analyzer. In this case, the data are quite similar, so we can take a look, and between the two, if we want, we can choose the worst case between the Monte Carlo and this 99.7% probability of drawdown. One thing you could do is apply a different risk level to each strategy used in the portfolio. In my opinion, this doesn't make much sense because the distribution of drawdowns doesn't follow recurring patterns. So, we don't have correlations between the drawdowns of the various strategies. Because it's random, today, 3 strategies might go into drawdown together, but next time, it's not guaranteed that the same 3 will go into drawdown together again. Maybe one makes a profit, one breaks even, and the other goes into drawdown again. So, in my opinion, that would be a bit of an over-optimization. I prefer to get a single value for all the strategies. The next values I calculated, which we have here in this table, are those of the worst day and the best day. What do they represent? Let's say that with this configuration, over these years of testing and out of sample, there was a day when we managed to lose a total of 5.45% in a single day. Whereas in the out of sample, it went a bit better. We only lost 2.66%. But this, I would also read this in relation to the best day, because the best day in our entire test was a day when we gained 11%. And here too, we have a ratio between the losses and gains of the best days that is about 2, so it is still something reasonable. In the last part of the data, we see that we have the maximum number of days in drawdown. That is, from when a new high was made, how many days passed before making another new high. In total, about 2 months passed, 38 days. So, considering there are 20 to 22 trading days in a month, that's almost 2 months. But we also have another important figure, which is the maximum number of consecutive days making new highs. In this case, for 11 consecutive days, so more than 2 weeks, the system kept rising without going into drawdown even for a single day. Next, we have this Ulcer Index, which gives us an indication of how recoveries are made. The system has a relatively high value, which tells us that it's a good value. The system has a good value. The next figure I thought it was appropriate to calculate is the pain to gain ratio. So this tells us that for every day of profit, we have about 1.69 days of drawdown, which is still reasonable. We then have a daily expectancy percentage of about 0.61%. So on average, our system earns 0.61% per day. That might sound like a small amount, but if you keep compounding your gains day after day, using them for new trades is actually very positive because your capital really grows a lot. The daily Sharpe ratio is about 33. Then we have a percentage of days in which we reach new highs, which is about 37%, while of course there are many more days when we are in drawdown, because this isn't a system that increases capital systematically every day, perhaps often having a negative floating. This is a system that works with stops and targets. Thank you. So in most cases, it doesn't create new highs every day. It makes a high, then goes through a period where it drops slightly, then makes a new high, and so on. The last thing is the overall profit factor, and we have a value of 1.42, 1.41, so similar in these periods, which is still an interesting profit factor value. In this first chart, I have represented the equity line of my out-of-sample period, which is what interests me the most because it's the period where I can understand whether the system performed well or poorly, and whether it reflected what I had seen in the tests. So we started from 10,000 at the beginning of the year on January 1st, 2025, because that's the period when I had completed all the tests. And from here, we can see the equity line. Now I've zoomed in a bit to see it better, and we can see that it has a fairly linear equity, which rises. As we said, we have a reduced drawdown, and it rises more or less in the same way throughout, even though, as we can see, there are periods like here and here, where for several months, maybe 2 months, there haven't been any significant new highs, and we've been moving sideways. This is precisely because it's a system. It's actually a whole portfolio of systems that work with stops and targets. So you will never see a linear equity line rising while the balance below is dropping, as happens, for example, with martingale systems. Then we see that there are days when the system earns a lot because we manage to catch those significant directional moves, entering a position and closing it by the evening. So these are the days when we have risk-reward ratios on a single trade that can even reach 5, 7, or 8. And if this happens on 2 or 3 trades in the same day because the markets are moving a lot, it leads to these steps of growth in our equity line. Below, we can see the chart of our drawdown, so we can observe the trend. We've stayed, as we saw earlier, below 11%, and here we have the entire distribution of our drawdowns. Let me know in the comments what you think about the results I've achieved. If you have any questions or curiosities about this portfolio, or if you enjoy the videos I'm sharing on this channel, don't forget to subscribe, leave a like, and stay tuned so you don't miss the new content coming out in the next few weeks.